If you would recall, we've been talking about definite integral. What we have done is actually added to stuff that we already know. If you recall, we have looked at the sign of the derivative telling us about the direction of the function. We know that when the derivative is positive, the function is increasing, and that when the derivative is negative, the function is decreasing. What we now know from our fundamental theorem of calculus is that the area tells us the amount of increase and decrease. So this is from the fundamental theorem of calculus. Part 1. The sign of the derivative tells you the direction of the function. The area tells you how much of an increase or a decrease we see. So if, for example, let's say, for example, we're looking at a graph of a function. Say that this happens at 0, this happens at 2, and this happens at 5. Let's say that this area down here is equal to 7. And this area up here, clearly bigger, let's call that A2, and say that that's 13. And let's read this function as capital F prime. This is the derivative. So this is the derivative of capital F. What we see is between 0 and 2, the derivative of capital F prime is negative. So the function is decreasing. What we now know with the fundamental theorem of calculus is that the definite integral, that the area tells us how much of a decrease. So from 0 to 2, capital F decreased by 7. So we know additional information. We see that on the interval from 0 to 2, since F prime is negative, capital F is decreasing. Since the area is 7, capital F decreases by 7. So on the interval from 0 to 2, capital F prime isn't going to be negative at 0 and at 2. So let's say on the interval from 0 to 2, where x is strictly between 0 and 2. On the interval from 0 to 2, capital F prime is negative. Therefore, capital F is decreasing. Since the area between the x-axis and the function is 7, we now know that capital F decreases by 7. If we wrote the definite integral from 0 to 2, of capital F prime of x to x, we would get -7. The definite integral gives you the amount of change. In this case, since we're decreasing, the change will be -7. So the way we interpret this, the definite integral, we would say on the interval from 0 to 2, capital F decreases by 7. Decrease because negative, 7 because area. The way we say F decreases by 7 is you say, take whatever the value that we had at 2, and if we subtract the value that we had at 0, we would end up with -7. That's from the fundamental theorem of calculus, and that would go right up here. And this would be the antiderivative of capital F prime is just capital F. The definite integral is telling us area and direction with the sign. And the fundamental theorem of calculus says this is the difference between capital F at 2 and capital F at 0. Where we ended up minus where we started, that's the difference. That's the amount of change. So on the interval from 0 to 2, capital F decreased by 7. When we started out with this derivative, sign of derivative telling us direction of function, we didn't have this part. We just said on the interval from 0 to 2, capital F prime is negative, so capital F is decreasing. Now we have additional information. Now we know by how much capital F decreased. We could do the same thing on the interval from 2 to 5. On the interval from 2 to 5, I spelled 2 wrong. Capital F prime is positive, therefore capital F is increasing. That we already knew. Now we have additional information. We know by how much the function increased. Since the definite integral from 2 to 5 of capital F prime of x to x is equal to positive 13, we could say on the interval from 2 to 5, F increased by 13. we're thinking of this definite integral business as accumulation or addition. Because that addition is what we do when we're multiplying, but things aren't all the same. The terms are not all the same. So that means if we integrate from 0 to 5, that will be the sum of the integral from 0 to 2 and the integral from 2 to 5. So if I wanted the integral from 0 to 5 of capital F prime of x dx, I'll just take the integral from 0 to 2 of capital F prime of x dx and add the integral from 2 to 5. I spelled 2 wrong again. So from 0 to 2, we had a -7. And then from 2 to 5, we had a 13. So the definite integral from 0 to 5 of f prime of x dx will be 6. That includes a decrease of 7 followed by an increase of 13 for a net gain of 6. If we think of this in terms of a table of values, if we think in terms of table of values, we only know how things are changing. When we find an antiderivative, there's that plus c at the end. I don't know where things started. I just know how things have changed. So whatever these values are, from 0 to 2, capital F will decrease by 7, followed by an increase of 13. We need to know something else about these values to actually complete a table of values. We would need to know 1 point for capital F. This would be like me saying, I drove south for 400 miles. Where did I end up? You don't know where I ended up because you don't know where I started. If I told you where I started, you could figure out where I ended up. I drove south for 400 miles, starting in San Francisco, so I ended up in LA. If I tell you where I started, you can figure out where I ended up. But if I just say I drove south for 400 miles, you don't know where I am. Any questions? Now I put the 5 too far away. I don't know why it was bothering me. The derivative is only telling us how the function is changing, not where the function is. This is the table version of what's plus c. If I gave you an additional piece of information about F, then we could figure out what the plus C is. Then we could figure out where everything is. So if, for example, I told you that capital F of 0 is 4. Knowing one point on the function, on a particular antiderivative, completes our picture. It allows us to figure out what the plus C is. So if F of 0 is equal to 4, I can plug in my table gets filled in. So from 4, we decrease by 7 to a -3. And then from -3, we increase by 13 to a +10. The derivative just told us how things change. Decrease by 7 from 0 to 2, and increase by 13 from 2 to 5. The derivative says we drove south for 400 miles. F of 0 equals 4 says we started in San Francisco. If we had additional information that looked like this, let's say F of 2, we just, we got to note where we are halfway through our journey or partway through our journey. We take a note of where we are. So let's say that F of 2 was equal to 11. It shouldn't take me that long to generate a number. So if I'll pick a number, I might go, that's tricky. But with this information, at 2, we have an 11. The derivative told us about the changes. From 0 to 2, we should see a decrease by 7. And from 2 to 5, we'll see an increase of 13. So 11 plus 13, that means F of 5 is 24. And we must have started F of 0 at 18 because we decreased by 7 and land at 11. So here's our table of values if F of 2, capital F of 2 is equal to 11. The derivative, the antiderivative is giving us a family of functions with a plus C at the end. If we have an additional piece of information, we can figure out what the plus C is. How's everybody okay? This is what Friday looks like. Right? We think about Friday as being kind of a happy day. But Friday, especially in your first class, I don't know for many of you, this is probably your first class. You can tell that this is your first class because we're latest for this class. Right? This is my most late class. It's okay. I'm not like making fun. I say that I get here at 8 o'clock, but I mean, really, it's like 8:15. But on your first class on a Friday, even though Friday is a happy day, it's not a happy day in the morning because you still have to get through this day. The reason that I can tell that a lot of you are thinking that because this is what it looks like. So I just need to get through today. Then it's the weekend. Don't give a shit what happens today. Just need to get through it. Get to Friday afternoon. I can worry about it on Sunday night. Is Monday a holiday? No, I can worry about it on Sunday. And that's when I will worry about it on Sunday. I check logins. There won't be logins on March 16 and 17 because that's this weekend. Unless I check Monday morning, then there'll be some logins on like March 17 at 11:45. And it'll be for like 2 minutes because you're like, oh, I'm going to get my homework done. And you like log in, you're like, oh, no, I'm not. Which is correct. That's like the correct answer. It's the worst one is when you see there's a login on March 17th, on Sunday, March 17th at 11:45. And it's on, and you're on for like 4 hours. I go, don't be doing work in the middle of the night like that. That's terrible. It's bad for your mental health. If shit ain't done at midnight, shit ain't getting done, and it's okay. Questions? Comments? At a certain point, you realize that a lot of the threats that were leveled at you about college in high school aren't exactly true. I don't know why high school teachers are like that. So here's a problem. I didn't want to make copies. Here's a problem. It's capital F is the antiderivative of little f, and I've shown you little f. So the important thing that we want to note here is that I am showing you what the derivative looks like. Capital F prime is little f. That's what we mean when we say capital F is the antiderivative of little f. That means capital F prime is equal to little f. That means little f is the derivative of big F. We're looking at the, I was about to point at the screen. Actually, I was about to point at the paper, which is not going to show up. Then I was going to point at the screen, and you can't see that either. Yeah. Those of you playing along at home, you can't see what I'm pointing at. Don't tell them. So this graph here is the derivative. I want you to read this graph for direction of the function and concavity of the function. And then I want you to figure out a table of values. And then I want you to sketch the graph. Notice that I can't just give you the derivative and say, fill the table of values for the function. I have to give you somewhere to start. So I've told you that f of 0 is -2. I have to give you somewhere to start because I have to vertically locate where this graph is, where this function is. All right, take a few minutes and think about this function. Then we'll break into teams and make sure that we all have the right function. All right, let's take the rest of the time to gather into teams or subgroups. Packs. Do students travel in packs? Packs. Break into teams with the cards according to the boards. And sketch. Fill out the table, sketch, describe your intervals. Please.